This clip's about transformation of shapes, and when I first mention this to pupils, many of them instantly think of one of two things. Many of them think that we'll take a shape and use a little bit of magic to instantly transform it into a different shape, or indeed something completely abstract, like a bunch of flowers. Or they think about Optimus Prime and robots turning into cars and aeroplanes. Well, transformations are neither of those, and there are three basic types that I'm going to talk about. One is translation, one is reflection, and the third one will be rotation. Now, translations are nothing to do with languages, but in fact we'll actually take a shape and slide it from one position, that same shape, slide it from one position to any other position. So, a translation will actually take an original shape and map it onto another shape by effectively sliding it from its original position to the new position. Now we use what we call vector notation to show this effective sliding. How many squares across does it move? How many squares does it move up and down? We consider the horizontal movement first of all, and it's important to consider the same point on the original as on the actual transformation. So how many squares has this moved across? 1, 2, 3, 4, 5. So in terms of our vector notation, that would be 5 there. Now it's moving in a positive direction, so this is a positive 5. We now consider its vertical movement. How far up has it gone? Well, in the case of this example, it is 1, 2 squares. So our final vector notation would be 5, 2. What if then this was the original and this is my transformation, my translation in this case? Well, again we consider the horizontal movement first of all. How far across has it moved? Well, 1, 2, 3, 4, 5 squares across. Now the vertical movement, 1, 2, down. Now in both cases it moved further towards the negative region. So in fact, from there to there is a translation of -5 and -2. Your transformations don't have to be confined to just this quadrant. I have this example here. Consider this as your original. What's the translation to take that one from here to here? Pause the clip, have a little go, and now I'll go through the answer. Horizontal movement first of all. 1, 2, 3, 4, 5, 6, 7, 8 across, and then 1, 2, 3 up. However, you must remember that this moved in a negative direction, this moved in a positive direction. So our vector notation would be -8, 2. -8 across, 2 up. Rotation is the next transformation I'm going to talk about. It's actually my favourite, probably because it's the easiest one to understand, I feel anyway. So, I'd like you to consider this is our original shape. What have I done to transform it into this shape? Well, in fact, I have rotated it 90 degrees clockwise about the point 0, 0. Just to show you that again, it is rotated 90 degrees into this position clockwise about the point where my finger is, which is the point on the axis of 0, 0. And that can be written as 90 degrees clockwise about the point 0, 0. The centre of rotation is that coordinate 0, 0. What about this rotation? This is my original. What transformation have I used? What rotation have I used to get it from there to there? Pause the clip. I don't know if you can get a bit of tracing paper on your computer screen, but it is often useful to use. What's the transformation? Did you get it? Well, the rotation is actually anti-clockwise, 90 degrees anti-clockwise about the point where my finger is, which is actually 1 across and 1 down. So the notation would look something like this. 90 degrees anti-clockwise about the point 1, -1. Reflection is the final one that I'm going to talk about, and this is also relatively easy. This is my original. What have I done to it? How have I transformed it from there to there? Well, in fact, it is a reflection, and it's useful to consider mirrors in this situation. So I can see on this simple example that there are 3 squares between the y-axis, 1, 2, 3, and my original shape, and there's also 3 squares, 1, 2, 3, between the y-axis and my transform shape, my reflected shape. So in fact, my line of reflection is the y-axis. My mirror line is the y-axis. Now I'm going to try and show this using a mirror, putting it on the y-axis. I'm not sure if you can see that on the camera, but it should look pretty similar when I remove it. like so. Now my line of reflection doesn't always have to be one of the axes. So in this example, this is my original shape, this is my reflected shape, but what line have I used as my mirror line, as my line of reflection? Well, I should be able to show you using this. If I flick that over to there, we can actually see that the line of reflection is here. And this is at the point where y is equal to -1. So that is my mirror line. So the notation for this example would simply be a reflection in the line of y is equal to -1. I'll try and prove it with the mirror. So I'll place that on that line of y is equal to -1. Hopefully you can see from my mirror there are 1, 2, 3 squares before I hit the original. And in the mirror you should be able to see there are 3 squares from the mirror going back into the reflection before I hit the reflected shape. I hope that helps.